Ladies and gentlemen, welcome back to the YouTube channel. Today I would like to show you how to use a TensorFlow model, what we have created earlier in your data processing. In the TensorFlow website, there are many useful sources how to create and use a TensorFlow model. We saved it as a TensorFlow Lite, which is suitable for mobile and edge devices. Our model is saved here as a model TF Lite in the sheet folder. The sheet is the project where we try to predict sunburn damage of fruit in the orchard. The data file, what I can use, have 10 parameters related to weather forecast or the weather station data, including temperature, solar radiation and relative humidity. The last column, damage, will tell us whether we can expect sunburn damage or no. It has the value of 0 or 1. So this is our data file. I will set this as a working directory so I can access the files very easily just by name. And I will make a Python script for that, and in comments I will write that this is the sheet data processing with TensorFlow Lite model. Okay. We are now in RStudio. This is a free software primarily designed to use R, statistical processing. And now I would like to switch to Python. So I start Python environment. First, as we start any Python script in RStudio, it will trigger the reticulate package and ask us whether we would like to use a separate environment. No, I don't want it. And with the answer no, I will have a prompt using the full-featured Python installed on my computer. So from now we can use everything which is already on my computer in Python. I need libraries. Because of the data manipulation, I will use NumPy. So I will import it as NP. I will use pandas library to read the data file. And of course we need the TensorFlow. So import TensorFlow as TF. I will run all of them to see that they are working. We can import all of them, and it also helps me editing, because after that it will offer the functions as I start typing. So the next step is read the data. Read our data file. The data source will be created by pandas. So panda read the CSV file. The name of the file is data CSV, as you can see here in the sheet folder, and the column separator is semicolon. I will use that. As I run, no error message, everything is fine. Here I can see that in the environment I already have a data frame, 53 rows and 11 columns. Now the problem is that maybe your computer is using 64 bits, but I need different file formats for the TensorFlow Lite model. So I will modify the data format, and it will be 32-bit. Float real numbers 32-bit. Okay, it is created. And then I can select the features what the model should process. The features are the first 10 columns, but the TensorFlow is using the so-called tensors. I have to convert my data to this so-called tensor structure. Convert to tensor, and the tensor will be the first 10 columns. So the data source I will locate where the information is. All rows, and from the first column, which is indexed 0 up to 10. So these will be the features I'm going to use, and you can see that now the features are created here, the selected data. Okay, we are ready to apply the model. We have to create an interpreter first. So the TensorFlow Lite model will have an interpreter. And the model path will be the file name, model TF Lite. This was created here in the sheet folder, so I'm creating it. Okay, now I have the model. So I can start working on the interpreter. I will remind it what is the input format. It should know that it can expect 10 columns. So I resize the tensor input. The information, the size is given already in the interpreter. So with the get input details as a function returning a structure, the first element has a so-called index parameter. It will show us this size. I would like to process all data once, so I will give it the size of my input data. So the shape, I will use all rows, but only 10 columns. Okay, now it is ready, and then I can allocate the tensors. I can book the memory to use it and prepare the processing. After that, I prepare the container to have my data. I can set the tensor, what I have to process. The get input details will tell what is the size. I just made it previously, so I adjusted already in the index parameter. We can find it, and then the features will be used. So now everything is prepared. Running the model is super simple. I just run invoke. As we are ready with that, I can get the results, because we are doing that to know what is the decision made by the model. Get results. Until now I did run everything one by one. Now I will do a bit longer. The prediction will be the result of the interpreter, so I will get the tensor. Get tensor. What kind of tensor I get? According to the output details. Again, this is a function which gives me a structure. So the parameter index will tell me how I receive the answer. So in the environment, if I run the interpreter is already created, I will get the prediction. And now you can see that in the prediction, I have answers based on the features. And then I can start processing it. For some reason I can see only one number here. I will run everything from the beginning to see that I can get it. Oh yes, I have numbers here. But as you remember maybe, the damage was scaled 0 and 1. 0, no number damage can expected, 1, yes. So the answer will be the prediction all rows and the first column. And after that I will make a threshold between 0 and 1, so 0.5. What is below will be 0, what is above will be 1. So the numpy where function will be used for comparison, and where the answer is below 0.5, I will give the value of 0. All the remaining will be 1. I'm a bit lazy, so I just copy paste. The remaining means that what is higher than 0, we didn't modify earlier, then it will have the value of 1. After that, we can compare with the observation, because in the data file we had the assigned damage. So in the index, I will check whether the answers agree with the observations. In the NumPy, where I can compare, and I will say that where the answer and the data source, again all rows, but the last column agree, there is no difference, so the difference is 0, I have agreement. And finally, because I know what is the list of the correct recognitions, I can print this information to the screen. Let's say I have correctly classified number of second parameter. Maybe we should provide it as a percentage too. I will calculate it as a floating point number with 2 digits, probably is enough. And we'll give it as a percentage with the unit. With the format, I can provide the data, what will be in the printed report. Of course, the index shape 0. How many elements are in the index? The agreed results. Then, how many rows I had in the data set? Shape 0. And the percentage, so 100 times the divided values, index shape 0 divided by the data source shape 0. Okay, I hope I didn't make any mistake in typing. So the prediction was ready, and now I make the classification. It seems that 53 is correctly recognized out of the 53, so 100% accuracy it is running. And now we can see that the answer is already transferred to 0 and 1 values, comparable to the data file. So this is how it is working. Actually, I was cheating a little bit, because the data file, what is here, is what we used to teach the model. So I expected that it will be recognized correctly. Now you can see how to process this TensorFlow Lite model in your application or in RStudio. Have fun playing with it. Thank you for your attention.